Well, gentlemen, here we are today. We're here to talk about this beautiful AMERITRON AL-811H that's here. Let's get out the note. That way I got all the information you guys got. He filled out a ticket system, which don't do this because I've never looked at these. My wife put that system on the web page and I've never ever used those for reference. I'm the kind of guy that likes to talk to people on the phone and get their own exact words of what happened. Let's see. This is a very well written note. First off, thank you for choosing to work on my amplifier. I purchased this amplifier from the HRO on June 12th, 2011, new. All that has ever been done to it is the LED meter bulbs. The old ones burned out. I'm no tech, so it might not be perfect, but it works. Looks all right to me from here. I replaced the 811A tubes with the RF parts 572Bs on September 5th, 2019. Never really saw a big change. But as time went by, I noticed the relays made much more noise. Finally, on September, January, February, so a year and 3 months later, 2021, all working well, then all of a sudden the relays made a very bad noise. My SWR went through the roof, so I shut it off. Took the amp out of the loop and did a coax antenna check. Good job. Most guys can't. Yeah. With low power, first then up to 100 watts max. All checks, also using my Rig Expert AA30, checks great. I only operate CW, so all my antennas are tuned for portions of the band. Yay, doesn't ever use an antenna tuner. Smart man. Because an antenna tuner, all it does is make your equipment think everything's okay. Actually, having a resonant antenna, much better. So I've removed the tubes, and they are shipped to you in a separate box. The amp is in its original box, but both boxes, once again, by FedEx ship, blah, 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 blah. Just check it out, whatever you think, I'm sure, blah, 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 blah. Never run it over 500 watts, mainly use it on 20, 40, and 80 with about 50 watts of drive and an ICOM 7300. Okay. I'm assuming when you change tubes, you know, the 572B and the 811A share a lot of the same characteristics. The 572B has got more plate dissipation. And if you put a little bit more drive in it and retune the amplifier for those tubes, you probably would have seen some more performance. I'll go with that. The 572B tube does put out more power than the 811As, and they're using these little tiny fuck all 5 amp relays down here, which I don't think I have any more replacements of, but I got other stuff that we can steal them out of. It'll be okay. If this is truly just a relay problem, this is a little bit to do. How this amplifier is set up is that we take the back and we can lay it down. So we undo these 3 screws across the back, the couple up here in the top. We're going to disconnect this shaft. This is actually heat shrink that runs this whole length of thing. And it comes back here and it attaches to this band selector in the back. This is your input selector. This is your output final PA. So we're going to have to get in here and cut this heat shrink. We'll have to replace this whole length of tube. That's not a big deal. We'll probably be able to shorten this up because I'll use heat shrink with epoxy on the inside of it. So we'll be able to get a better connection over a smaller amount of surface area. As always, the 10 meter modification is right here. Just so you guys know, it's this green wire right here and this little hunk here. You want to do just like this guy did, clip this wire, and all this is a wire that goes to ground. It takes the 10-11 meter input portion of the amplifier, ties it to ground so no RF can come in. As we can clearly see, we do have the 10-11 meter position But let's go figure it out. The relays made a horrible noise. Well, let's slide the back off this thing and let's go look at what might have caused the horrible noise. Okay, let's get this done here. So this only took quite a few hours to get these out of there because they're through-hole soldered, and they use a higher temp solder, at least on this older version. They don't do it today on this older version of amp. So let's get our little alligator clips set up. And when we touch the tips together, of course, we're going to get beep, and it's going to show us resistance. Of course, we want to get a heavy meter. We're going to go that direction, but this is more than adequate for today. The way these relays work is input signal comes in here, and it is either switched from here or to here. The same thing comes in here, switched either here to here. So first we're going to check this here, which has got good conductivity. And we've got good conductivity. So now let's see if we can hook up 12 volt and not have anything short out. So we'll grapple that, and we're going to hook up here. We got good conductivity. And we got good conductivity, and we got good relay movement. So that relay is good. Now this uses a pair of relays in this amplifier. Two, one there and one there. So let's repeat the process from just a minute ago. So we'll hook this up. Got good conductivity. And we got good conductivity. Let's make sure we got relay movement. Click, and we do. Attach here. And we got good conductivity. So the relays are not effed off. Now these are sealed relays, but if the contacts in here had been messed up, it would show up as resistance, and we're just not seeing it. That took a lot of hours to get those out of there. Well, I got a choice. Either I can replace these two $10 relays, which I'm currently out, so we've got to sit and wait for, well, till next week, until those parts come in. Or we can put this back in the amplifier and we go find out what really quit, if anything. I don't know, the relays don't make a lot of noise in this box. They just don't. So I'm kind of leaning towards the idea that maybe it's not the relays. Just saying. I'd rather replace relays. I'm going to set this thing aside. I'm going to come back to this in a couple days. We'll put the new relays in it. And between now and then, all I got to do is I got to bag up all the screws, itemize all the parts, and we'll set this thing aside and I'll come back to it in a couple days. I was hoping off his paper description that we could run right to the problem. I just don't see anything burned in here. We'll see. We'll see. Okay, so I'm back on this guy for a little hot minute. I am happy to say our new NTE relays have come in. So I don't think we should have much of an issue here. Slid right in the hole. These little boogers are getting expensive. Remember when they were only like a couple dollars a piece? They're like $7 or $8 a shot now. That's okay. So now, my mission, if I choose to accept it, is because these are through soldered. Now, you guys in video land, it was 30 seconds ago, but to me, this was, geez, an eternity of projects back. So this is a trick to do because it's through soldered, so you got to solder it and it pops. Goes bloop, bloop. And then you know the solder's made it all the way through the joint. Bloop, 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 bloop. There it goes. Okay. I'm here to tell you that took hours. And I mean hours. It took hours and hours to get those relays out without messing up those traces. And it took just like that long to get them back in there, but now the fun bit. To reattach this to that, and that to this, and this to that, and we'll get it all put back together. Okay, so here we go. This is all put back together now. Got the support bars in, the safety interlock bypassed. Got our band selector hooked back up. Everything's hooked back up. So now we're just going to turn it on. We're going to turn up with the old trusty ye old Variac here. And we're going to see what happens. So put the power on. Got that in high voltage. Let's go ahead and click on Variac. Oh, that's good. Oh, that's good. That's good. Okay, so we're sitting at 110 volts. Let's go ahead and click on the X emitter button there. All right. I'm sorry. If I had the board out and I went through the hassle to get the relays out, I'm not going to put the old relays back in there, taking into account how old this amp is. So, if anything, at least we replace the relays. I'm going to let the high volt bleed down. We're going to ground everything out. I got to get out my chicken stick. And then I'm going to insert the tubes, and then we're going to bring them up. And then we'll bleed it off again, and then we'll attach the high voltage to it. So give us a minute. 4 tubes in, Variac at 0. We're just going to see if the tubes light up, because I want to make sure nothing... We have no vacuum bottles, right? It's not fighting me. I can't tell if the tubes are lighting up or not. Okay. So we have no tube lighting up. No filament volts. All right. No filament voltage. Well, let's figure that out. Okay, so this is actually really dangerous what I'm doing here, so I got to be careful where I stick my hands. I got the amp on. I got the back hanging free. And what you guys can't see, well, here, hold on. And what you guys can see now is down here, I'm probed on the output side of the filament choke. Now we see these little black wires that run here. They're what run underneath and hook up to the RF deck. Well, I'm probed and I've got my 7 volts for my filament. Those tubes should be lighting up just as bright for like a country mile, man. Did this guy manage to F off his tubes? Okay. Let's kill this. I'm going to pull the tubes out. I'm going to probe into the sockets for the filament now. Oh. Okay. Well, we'll figure this out one step at a time. We've got the filament voltage from here. Now, is it making it to the bottom of the sockets? Don't know. Okay, so you see the little titty? That tells us that this is pin 2 and that's pin 4, or pin 2, pin 3, pin 4, pin 1. So filament's pin 1, that's pin 4, that's our filament leads. And then if I'm not mistaken, and I had to think back to when I was running around with Witch Doctor and Squeaker and all them guys way back when I was a duck. That's not connected to anything, and that's our grid. So we should have nothing, but if I hook my filament leads up here, which is what we're currently fighting with, we should have the filament light up. So what we built here is the Waffensteingler Hibimajibby filament tube tester, per se. I've got my old trusted 100 amp continuous duty EPD, designed to be a direct drop-in for the X-Force transformers. Power supplies, but actually this thing easily does 250 amps, just this one little transformer. Got it hooked up to the Variac, got our wire test probes attached to the multimeter here. Let's go ahead and let's start turning the Variac up, and we'll bring some filaments up. We'll see if the tube lights up or not. Yep, here comes the tubes. So right at about 6.3 volts, if I'm not mistaken. 6.3, and we're looking at about 4 amps. The fact that the tube lights up is all I need to know. We're not going to get too far down that rabbit hole. So we're going to put a check mark on this one and say the tube actually lights up. Now I have a feeling. Pull a check mark here right by the nipple. The nipple. We're going to set it aside. So now we'll go ahead and we'll hook this one back up. Slide that on there, slide that on there. And we'll repeat our test. There's 1, there's 2, yep, here comes the filaments. Oop, there we go. 6.3 volts. Okay, so this tube is good as far as filament is concerned. I'll put a check mark right by the nipple. Zip nipple. The nipple. The nipple. Okay. Let's grab this guy. And survey says nothing. Okay, so the filament is blown the frick out of this tube. Let's not get carried away. We're not going to put a mark on that one. Now let's grab this tube. Zip tipper. Zip tipper. Okay. All right. Let's turn this one up. Nothing. Okay, so this tube is bad also. Bad. So over here we have our two bad ones and our two good ones. Good as far as the filament lights. Now let's get this way overkill transformer out of the way for a moment. Slide you over here and you can just sit there for a minute. Now, I'm wondering, do we have a grid to filament short on any of these? So, once again, if I'm not mistaken, I'm going to grab the leg of the filament, set this to ohm check. We're going to hook up to the grid pin. Nothing, nothing, and nothing. This is our bad tube, one of them. Let's grab the other bad tube. Oh, Mary, Jesus, and Joseph. That's no good. Let's just tap it. Oh, we'll turn it upright. That's the lowest resistance is when it's facing upright. Okay. So we're going to put a big old X across this tube. No UZ for anything. This will straight up screw your box up. That has a grid to filament short. I mean, only the best the Chinese even can produce. Nothing, 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 nothing. Okay. Nothing, 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 nothing. All right. It's a good sign. So I have two bad and two effed off, straight up effed off tubes. Got our plate, got bias flop, we got our center taps all working on this. The filament is the only thing that I'm really in question at this point. And what I have questioned is how do they have the filament wired? And it should be series or parallel, just everything be parallel. Because the input voltage is only 7 volts. But I won't know that unless I can find a schematic for this that says yes, that's the case, or until I rip the whole RF deck out. Which really isn't all that big of a deal. It's disconnect this, undo this, that, and that, and then I can lift the whole deck out. At least tilt it up so we can see how it's wired. So, RF deck's coming out. I would like to officially report to the universe that as of 2011, even AMERITRON grounds the grid on their 572B. Man, I am so tired of hearing that argument. Oh, you got to put a choke between the grid on the 3500Z and the 572. No, you don't. Ground that son of a bitch. Okay. What we're looking at here and what we hear beeping is a voltometer telling me that I've got conductivity from this wire back to the filament lead. And let's go over here. And I got conductivity from that wire back to the filament lead. So what we have learned is that we got filament. Enough of that beepy shit. Everything is parallel. There's no series of anything. So man, I should be able to put those two tubes that light up in here, and they go. You should be able to light up. Interesting. Very interesting. And very carefully put this back together. We're going to leave this disconnected for the time being and attach our chokes. I will put those tubes back in here and see if we can get them to light, because I can't figure out a reason why the two that are good, these two guys, why this one won't light up. See, got check mark by the tit, by the nipple, das nipples. Okay, let me put all this back together. We'll figure it out. That's what I wanted to see. All right. Now I got to go through and I got to find two more 572Bs. I've got a box over here that's got about a dozen of them in it. The $64 million question is, where's that friggin' box? Let's see if I can find a couple good 572Bs in this, so I can go back to the guy and say, hey man, figured it out. The only problem he had is that two tubes go bad. I don't know why, but he had a ground short on them, grid short on one, filaments were fucked out on both of those. Effed off amongst both of those. And I can go and put all this back together now. Interesting. Why didn't that work the first time? Okay. I've got two of my tubes in here and his two tailors. Those tailors are about the end of their life. Let me show you what I mean. This is going to show us two things. That we're low on output across the band, which I'm pretty sure that's what's going to end up happening, and that it works on all bands. So I got it all put back together. Everything's tested. Even got the ALC all hooked back up. I'm real proud of myself because I left it disconnected there for a hot minute. This is 1,000 watt. No, not 1,000 watt. Here we go. Now it's 1,000 watt. Okay, 1,000 watt in peak. It was 1,000 watt in average here for a hot second. Here's the radio at 012. We're in 160 meters. 160, right there. And let's put the amplifier in line. At 012, 700 watts. Let's look at our grid meter though. In the corner, audio. Tubes are at the end of their life. The tailors are anyhow. Let's jump up here to 80 meters. Take the radio. The input tune on this thing is great, by the way. Let's see here. AM. And if anybody that knows me knows that I'm not a big fan of these amps. They just are, especially on the 11 meter band. They're way not designed to run there at all. Okay, let's switch over to sideband, SSB, and our power up to 100%. Hello. One, two, 1, 2. Okay, so we're working on 80. Hello. Pulling 200 mils of grid current. Hello. 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 We're maxed out. This is way high. We're at 6. Or on the plate current's about maxed out. And our grid current is just about in the death zone. It's at about 650 on our best day. So, 500 to 600, somewhere in there. We're at the end of life on those tubes. So let's go ahead, we'll jump up to 40. 40. And let's come over here. Jump to 40, go to AM, AM. Back this down a little bit. Dip the grids. We're going to go to a sideband. Hello. Once again. Hello, 111, hello, 600. So we're right at the end of what this is going to be doing. Hello, 572B is way rougher than the 811A. Way tougher, way rougher, badder man, in my opinion. Hello, 1, 2. Okay. Remember, our main point is to be able to show that the amp is now working and working safely in all modes, and then I can go back to the customer and say, okay, this is what I found. Go to 20, go to AM, and these are your solutions. That's our main goal. Oh, wow. Grid's dipped. Hello. 1, 2. Hello. That's with them dipped, by the way. Hello. Now the up advantage to go into the 572Bs is, yeah, you can put a little bit more drive in this. Not a lot, a little bit more drive, and you get a little bit more power, but okay. 21 AM. Input tune has been beautiful on all these bands, by the way. So close enough. Let's go to sideband. At 012. Okay. At 11111. At 01111. At 0111111. At 01111. Okay. Not even bothering going to the aux position. Doesn't matter. I gotta let this cool down because I gotta pull my 572Bs back out of here and let it cool off. The moral of the story is, gentlemen, when your filaments go out and they short to your grid and you get a grid to filament ground, loop return, I mean, could that... The only thing I can think is that when the filaments went bad and it shorted back to the ground for the grids, it was pulling all the filament voltage, but man, that sucker would have gotten hot, and I didn't see that. Oh well. Relays have been replaced. Figured out what was wrong with it, diagnosed the problem, proved that it's fixed and repaired and ready to go back into service. Now all this guy's got to do is go buy himself a couple 572Bs, and his ass is back running the big show. I have himself a good time getting back on the air. And I cannot wait to return this thing to him. I got this right at the tail end of me taking on work, and it has sat in another place, not out here, but in another place for almost a year. And finally the wife's like, can you take that out in the shop? And I said, well, better, how about I just repair it? So, done. This has been a strained last couple weeks for me, you guys, I'm not gonna lie. But I'm slowly getting all these big projects out of here. I spent $700 today on just 2 transistors. What is the world coming to? My Lord. You'll see the video here in about a week or so. Well, gentlemen, on that note, I'm done with this. It's going to go back to its ham radio friend. It's going to go back to its life and live an easy life with 100 watts worth of drive. And I'm going to tell him what I found, and this is what he's got to do. I appreciate y'all tuning in to follow the little antics that I've got going on here, my little show. I want to say thanks to every single one of you guys, and big shout out to Siglant, Excess Power, MechMan, Coaxial Dynamics, and Bird. Gentlemen, from the bottom of my heart, I say thank you. I think I need to go eat me a sandwich. I'll see you. Click, click.